Hi everyone, welcome to the second part of Mining Cave's presentation on the Ordovician period. My name is Jessica, and I have a lot of interesting facts to share with you about our era. Kay and I staggered our parts, so she covered the introduction and life, where I'll be covering global events, what was going on in North America, interesting finds, where the plates were, rocks, where to find them, all that good stuff. So, where were the plates? The Ordovician period can be broken into three parts, early, middle, and late. During early Ordovician, most of the Earth's land was collected together in the supercontinent Gondwana. Gondwana consisted of southern Europe, Africa, South America, Antarctica, and Australia. Throughout the Ordovician period, reminder that's 45 million years, Gondwana moved towards the South Pole where it stopped in late Ordovician. During Middle Ordovician, Western and Central Europe were separated and located in the southern tropics. Europe moved towards North America from higher to lower latitudes. All of the shifting triggered one of the biggest global events at the time, the second largest extinction in history. Due to Gondwana shifting towards the South Pole, glaciers formed, which caused sea levels to drop, draining shallow oceans and decreasing volcanic activity, and also drops in carbon dioxide production. And then during the Middle Ordovician, there were also uplifts in areas that were under shallow shelf seas, which is said to be a precursor to the glaciation that caused the extinction. I've read several different scientific opinions on whether or not this caused an ice age, but that seems to be the leading consensus. Europe moved towards North America, causing the Atlantic Ocean to close, and climate fluctuations became more and more extreme as glaciation continued. And then here in late Ordovician, the South Pole can now be seen as an ice cap, which Laurentia, present-day North America and Baltica, which included part of modern Western Europe, can also be seen. And all the major tectonic plates were moving during the Ordovician period. So now on to key global events. Ordovician is home to the first primitive land plants. 470 million years ago, due to the GOBE. I'll go more into depth about the GOB just here shortly. Short-rooted plants like moss and liverwort covered the land, or what was exposed of the land, because there wasn't much of it at the time. It was mostly just oceans. Tim Lenton of the University of Exeter, United Kingdom, and his colleagues think that these mosses and liverworts were also the cause of the Ice Age extinction. I mentioned earlier that there's a drop in carbon dioxide levels. Basically, what these pesky plants did was feed off the nutrient-dense bedrock, leaving behind chemically altered rock that cannot react with CO2. So this is also thought to be the reason for the Ice Age in the Devonian period as well. And then, I don't know if you guys see the liverwort plant. It reminds me of that picture of SpongeBob of the nasty Krabby Patty. Just cracks me up. And then moving on, we have this map right here. I'm sure many of you recognize it as the Appalachian Mountains. But what was interesting news to me, and hopefully to y'all, is that there's another name for these mountains, and that's the Tectonic Mountains. During Ordovician, Tectonia, a tectonic highland, formed along the margin of eastern North America. So every time you've heard or read about the Appalachian Mountains, you're hearing about something that was created during the Ordovician period. So another interesting fact is that due to the mass extinction at the end of the Ordovician period, where 60% of all marine species disappeared, an abundance of fossils and multiple major petroleum and gas reservoirs were created. So this image here is showing the Carboniferous top, the Silurian top, the Ordovician top, and the Ordovician Cambrian top. And then you can see here, the majority of the reservoirs are concentrated in the Ordovician top. So that's like the red deposits. And this was like one of my favorite facts. The highest rocks on Earth, marking the summit of Mount Everest, or Ordovician limestones. So they were once deposited in warm, shallow water sea some 450 million years ago, and now it's at the highest peak, the highest summit of the Earth, so I thought that was pretty cool. So pictured here, I have the GOBE and the extinction, the second largest. So I'll talk about that first. I kind of touched on it briefly. The reason for the Ice Age had to do with the multiple factors. Until recently, the glaciation was thought to be primarily caused by Gondwana shifting towards the South Pole, but scientists today say that the primitive plants that came into existence at this time were to blame. But it's really just multiple factors. And then we have the Great Ordovician Biodiversification Effect, or GOBE for short. During the Cambrian period, we learned about the different phyla that evolved during this time. Phyla, arthropods, annelid worms, mollusks, etc. These different species experienced significant biodiversity during the Ordovician period. There are several different biological and geological factors that attributed to the GOBE. So during this time, we saw the highest sea levels of the Paleozoic. And then due to pronounced volcanic activity, there's an enhanced nutrient supply. So they were all just like eating good, living good, like life was good. Researchers call it a near unique paleogeography, which basically means that everything where the plants were located to the climate and atmosphere, the life just were perfectly working together. The GOBE caused a switch from the microbial dominated reefs in the early and middle Ordovician to Metazoan dominated reefs in late Ordovician. And sadly, 6% of life would become extinct during the end of the Ordovician period. So the GOBE party had to end. It ended. And then what was North America like at this time? Well, a term to describe the geological features during this time in North America, which was still mostly underwater, is karst topography. Karst topography is a type of landscape where dissolving bedrock has created sinkholes, sinking streams, caves, springs, and more dangerous features. So you wouldn't want to go hiking in a place like that. It's very dangerous. And then late Ordovician, where, as I mentioned earlier, a tectonic highland or tectonia sprouted along the northeast coast. The tectonic terrains collided with Laurentia in this region, forming an arc of volcanoes offshore during mid-Cambrian and mid-Ordovician. The terrain reached across eastern Canada through New England, and then over time, this arc would erode and mix into the Appalachians. And then middle-late Ordovician hosts the tectonic orogeny, and orogeny is the process in which a section of the Earth's crust is folded and deformed by lateral compressions to form a mountain range. This is 3 separate collisional events from Maine to Alabama. It created deep basins along the eastern edge of Laurentia, which some are filled with almost 10,000 feet of sedimentary rock. These sediment-filled basins can be found today in New York and Pennsylvania, known as the Queenston Delta. Another cool place to find rocks that can be traced back to the Ordovician area is at the Adirondack Mountains in New York, which is just north of the Appalachians. These mountains consist of a core of pre-Cambrian rock that is surrounded by upturned Cambrian and Ordovician sedimentary rocks. And then bonus fact, the difference between the Appalachian Mountains and the Adirondack Mountains is that the Adirondacks are slowly still growing, while the Appalachians are not, because the Adirondacks are made of metamorphic rocks, and the Appalachians are mainly sedimentary. So you can also visit these parks that preserve fossils or rocks associated with the Ordovician period. There's Buffalo National River, Arkansas, Great Basin National Park in Nevada, Ozark National Scenic Riverways in Missouri, and Rock Creek Park in Washington, D.C. There's plenty more, like a lot more. I just named a few. And then during Ordovician, a very large, unique layer of limestone formed across the land. And compared to other sources of limestone, Ordovician dolomitic limestone possessed stronger, less absorbent, and less soluble properties. So as we know at this time, the Earth was covered in massive warm oceans and extremely high sea levels that had marine life thriving. Laurentia and Gondwana were teeming with early plant life and still almost entirely underwater. So with all this activity and due to the high sea levels, flat land masses, and marine life, most of the debris fell to the bottom of the oceans and turned into sedimentary limestone. And then that extreme pressure, that high pressure from the water, the oceans, compacted the limestone to be hard and durable, thus creating the difference between other types of limestone. And then by late Ordovician, Gondwana and Laurentia would drift apart, they had a bad breakup, and the layer of Ordovician limestone that formed would spread across the world, which is why you can see it in places like Mount Everest. Regular limestone scores about a 3 on the Mohs hardness scale, whereas Ordovician limestone scores a 4. And then just to put that in perspective, granite scores a 6 and diamond is scored at a 10. So Ordovician limestone is tougher and more resistant to natural breakdown and erosion. It can also act as a host for rocks like zinc, lead, and copper deposits because it contains less impurities. And then I just found this really cool map because I have a hard time putting into perspective like where the plates were at the time because it doesn't look like anything today. And then this shows what North America looked like during the Ordovician period. It has like the Atlantic States and Canada. So I thought that was super cool. And you can see Michigan's like almost entirely underwater. There's just a piece of like the Upper Peninsula that's not. So I thought that was super cool. Here are my sources. Yeah, well, thank you all so much for your time. It was really interesting to learn so much about geological history that has so much to do with today. I just want to thank Kay for being an awesome partner. And we hope you all enjoyed our presentations, and we're looking forward to your questions and comments. And also, everyone has done such a good job so far. I get really nervous with presentations, but watching the ones before me helped ease some nerves and guided me through this project. So yeah, just good luck everyone. I wish you all a successful semester, and thank you again for your time.